well. So, all right. So, guys, make sure that you understand the difference between finding a unit vector in the same direction and finding unit vector form. Okay. So. Number 10. Was that the addition one?
No, it's 3u minus v.
Yeah, 3u minus v. Okay. For one thing, guys, on where is it? When you're adding things and you're given vectors, okay, make sure you actually use the vectors that you're given, okay? Most people did that. Some people just kind of drew it however they felt like, and that didn't turn out too well for them. Okay? Why in the world did that? There we go. Okay, so vector u, the way it was given, it went over 2 and up 3, right?
Yes, you can do that, right? Okay. You can just like see where he ends. You see where he starts and then where his top is. Yes,
that's vector u. It was 2, 3. And some of you use the algebra to help you find the result. Okay, that's okay.
I was like counting like
vector v went over, what was it, 5 and up 2? Down 2? Okay, so 1, 2, 3, 4, 5, down 2. So here's v. Okay? So now, when you do 3u, now, you didn't have to do the algebra here, but when you do 3u, it was over 2 and up 3. So you started somewhere. Okay? Yeah. You go over 2 and up 3, there's a u. And then over 2 and up 3 more, and there's a u. And then over 2 and up 3, and you get another u. Or you just multiply, and you get 6, 9, and that's 3u. Okay? Now, the key is here, getting that minus v, because you were asked to find 3u minus v. Okay? When you do minus v, you need to go in the opposite direction, both horizontally and vertically. So instead of going to the right, I'm going to go to the left, and instead of going down, I'm going to go up.
What?
Alright? It's the opposite direction.
I'm
going to move this over here. Doesn't matter where it is. Okay. Alright, so instead of going to the right 5, I'm going to go from here to the left 5. And then instead of going down 2, I'm going to go up 2. So I should end up here. Okay? So the end result, my resultant vector is that. Okay? Now again, if you wanted to use the algebra to help you, you could have. 3u was 6, 9. Minus v would have been a minus 5, negative 2. So 6 minus 5 is 1. 9 minus a negative 2 is positive 11. So your end result, notice we went over 1 and up 11. Okay? Yeah, it's Biggie's thing. Anyways, so does this make sense? You should be able to draw them. Okay, that's why I gave you those ones in homework where you had to do this. But on top of that, you know, use all the tools that you have at your disposal to help you do it. Okay. So
if you ask to find the B, like question 10 for B, the green line, dash line, and you want us give you a point or like the vector point for it.
No, you don't have to give. You did not have to tell me this, but you did need to draw that label.
How do you find the vector?
Green line.
You plus together or? Because you just list upon 111.
Well, here's the thing. When I'm doing this, okay, if I just pick a starting point and I draw my 3u and I draw my minus v, okay, because this was my minus v.
Yes.
Then if I just draw a vector from the starting point to where I ended up, that's going to be b. Now, I can then look at the graph and say, okay, I went over 1, so that's my vector 1 something, and then I went up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, I didn't have to figure it out algebraically.
Wait, but you needed the coordinates of your.
No, you did not need that in your answer. I just told you to construct it and draw it and label it.
But you could give us a question where you need the.
Sure, maybe.
Can I have my quiz back, please?
Oh yeah. Yeah, Sam.
How many points is it tomorrow? I'm gonna test.
It's 100. Like.
I hope you were
So. Okay. Any other questions from the quiz? All right. What I want to do then is take questions from any homework problems that you might have tried and weren't sure about. We had problems related to work.
Really
And-
bad with the picture ones.
Yeah, I'm not a big fan of the ramps and
Yeah,
work.
like lion.
I'm really bad.
You're not really feeling the ramps.
Yeah, the
Okay.
ramps are all.
The one that was, I will say, 31 was a little bit tricky, and I actually missed a detail. Yeah, 61. I missed this detail. No, not this one. This one, 63. I missed this detail the first time I looked at it because I used the 1600 kilograms, but that's not a force. That's a mass. Okay? And that's why they told us that it was 15,691 newtons.
So you know, normally everyone's sort of like normally it's miles and kilometers.
Yeah.
This is like
So, in this one, you had your vector, you were pulling at a 30-degree angle, okay? You were pulling at a 30-degree angle, and the magnitude was 15,691 newtons, okay? So, our unit vector, we needed this horizontal component, okay? Obviously there's a vertical component, but for the work done to pull this thing an unspecified number of meters, okay, our work is going to equal the number of meters times this horizontal component, okay?
so this distance time.
So if I have that, the horizontal component, then it's cosine of 30 equals x over 15,691. So you multiply and you get 15,691 times the cosine of 30 degrees. Okay, that's our work in terms of d.
But then how do you find D?
Well, this isn't something that we're necessarily solving for, because in the next part they say, okay, find the work done if we pull it nowhere, or 200 meters, or 400 meters, or 800 meters. Question?
What's the formula again?
Okay, the formula, and I kind of skipped a little bit of this. Remember our work formula is the force vector dot product the displacement vector. Okay, and we used PQ. It doesn't have to be PQ, but it's displacement. So if you think about our displacement vector, it's really the vector d0, because we're pulling it along the ground for d meters. The force vector ended up being D time, or no, not D. 15,691 times cosine of 30 times, and sine of 30.
When do you use cosine and sine?
When you're trying to convert from a situation where you know the magnitude and direction to components.
How do you find the D?
What's the O? Distance.
Okay. 0. That's a 0 right here.
It's not legit.
Okay, so it's 15,691 times the cosine of 30, and then 15,691 times the sine of 30.
Yes.
But why do you have two coordinates if you only need one?
Well, here's the thing. We do actually only need one, and as you guys get more comfortable with this, you'll realize, okay, I really don't even care about that because of this. When I do the dot product, that's going to be 0. Really, all I end up doing is this times D, and that's how we get this.
Will you usually give us points on the unit circle?
Not necessarily. You got your calculator, so
So
shouldn't
is
make a
it-
difference.
It's all gonna be calculators tomorrow? Like no.
More of the quiz, right?
Yes.
test. Yeah.
How do you find the PQ?
PQ is your displacement. How far does it move?
So
It's not moving up or down at all.
so it's
But-
just one. So for this case, it's 1600.
This place at 1600. No, it's not 1600. In this case, the 1600 kilograms really is irrelevant. Okay? What we really care about is the actual force, the 15,000.
So how do you pull that formula to the word last formula?
Well, this was a dot product, right? So the dot product says you do the horizontal components multiplied together plus the vertical components multiplied together.
So it's
But notice the verticals you're multiplying by 0.
So also we need to use the 15,600 that thing times D.
Yes. Guys, please stop just chatting, alright? So, at this point, then you're just plugging in different values of D. Now here's the thing. Everyone that we've looked at so far has us just pulling it like along the ground or something. The fact of the matter is, though, we could pull it and actually have it end up off the ground. Okay? In which case, this would not equal 0. You know, if we pulled it 200 meters along and then pulled it like 4 meters up, okay, we would have to use this dot product a little more carefully because it wouldn't be 0 here.
So we have one more sign.
Okay? It would be this plus sine of 30 times whatever that was. Okay? Like if this tractor pulled the log and then, well, if the tractor doesn't make a lot of sense because it's tied so short, but let's say you had it on some kind of a rope or whatever, and you were pulling it, you know, at an angle 30 degrees, you know, straight or something. Then you would have to take into account the vertical lift as well. Okay.
And like 15,691 we times D first or
It's times this whole thing together is your force vector. Okay? That's the formula right here. The magnitude times the cosine of theta times the sine of theta.
distributing.
Huh?
So it distributes.
Yes, you would distribute that to both parts. Okay? There.
So like to know when to use sine is just basically looking at the picture, like see.
Yeah, look at the picture, look at your triangle. to figure out whether you're using sine or cosine or whatever. Okay?
So let's memorize all these.
You should already have these memorized. If
Yeah.
you're having to do a lot of memorization tonight, then you're behind. There we go. Thanks.
Yeah,
Yes.
How do you know, like, if they give you another, like, obviously you're gonna use 30 degrees with your sine and cosine because that's the only angle there. But like, there was another question where they gave you more than one angle and like I didn't know which one to use. Like, how do you know that third, you know, like.
Well, that's just the problem solving. You draw the picture, you got to figure out what they're asking you for and all of that stuff. Okay?
I can't even, like, I don't understand, like.
That's right.
He's going this way.
Yes.
So why does 30 degrees even matter?
Well, because the tractor,
Oh, because
it's
to make him go
attached-
straight, you
it's
need to.
attached right here. So it's pulling at a 30-degree angle.
We want to find work. We have to find the work done.
Yes.
So,
we pulled it a certain distance
and work is
at this
distance
angle
times
with
magnitude of the
this
force.
force.
It's like one thing in the
So-
player.
Oh, okay, I didn't see this on here.
Yeah.
Alright.
You do know,
But
like,
if it
you guys
was,
wondering?
if it wasn't 0, then it'd be comma.
Plus 15,691 times the sine of 30 times whatever that was. If we lifted it up
Oh,
off
yeah.
the ground as well. So. Alright, any other questions on homework problems? 61C, okay? Says find the force perpendicular to the hill when D equals 5 degrees. Okay? So let's take a look at this. The force perpendicular to the hill. So here's our hill. And here's the horizontal. We want it when there's 5 degrees here. Okay? So we want the force perpendicular to the hill. The weight of this is going straight down. That's the 30,000 pounds. Perpendicular to the hill is going to be like this. Okay? Now I'm going to blow that up a little bit so it's bigger so we can see it. Alright? So we have that. The magnitude here is 30,000 pounds. Okay? This would be the magnitude pushing it down the hill. We want this magnitude straight down here, okay, on part C. The force perpendicular to the hill when D equals 5 degrees. Now, we need to make sure we get our angle in the right spot as well. Alright, so here's our hill, and with the horizontal that makes a 5-degree angle, okay? Well, this is 90 degrees,
So that's 85.
okay? So this little piece here is 85, and that means the 5 is right here, okay? It's crucial that you get that angle in the right spot or else you'll get your sides swapped, okay? So we want this force right here. So we're going to use what of 5 degrees? Cosine. Cosine of 5 degrees equals x over 30,000. Okay. Multiply by 30,000 and you'll get your answer.
Big number.
It's 25, somewhere
Yeah,
around 25,000.
29,885.
29,885.
Yeah, 0.84.
Okay, so it's almost all the weight of the truck is going perpendicular to the hill, but not quite all, because we are sloped a little bit.
Can you use a law
What's
of
that, 5 degree angle?
sines?
You could use the law of sines.
So I tried doing that.
If you use the law of sines, you would have to know that this was then 85 degrees here. And you would have x over sine of 85 equals 30,000 over sine of 90. Did you use sine of 5 or something?
I put extra sine of 5.
Oh, okay. So actually, you found this
Yeah, I
side.
was trying to find that side and use the Pythagorean times x.
Oh, which would work. It would work that way. It's just an extra step. But
We find.
So you're always gonna have a right angle. You just have to find out where it is, and then you can like subtract.
yeah, basically, you gotta make it work out.
Okay.
So.
On your test, we're gonna have to like draw our own triangles, or we'll.
Some, yeah.
Use
So.
Triangle.
All right. Any other questions from homework?
Think of it.
Okay.
100.
Here's a good review question. If the dot product is 0, what do you know about the angle between the vectors?
All have a 0.
It's 90 degrees, which means the two vectors are
Orthogonal.
orthogonal. Good. If the dot product is greater than 0,
Does that mean they're less than 90?
it's
They're in the first.
it's less than 90. It's acute. It's an acute angle because that's going to make our cosine positive, which takes us to the first quadrant. Okay. And then if it's negative, obviously our angle would be second quadrant, obtuse. Okay. Remember, we don't care about the third or fourth quadrants when we're talking about the angle between vectors, because we're always, we're always looking at this angle between them, not this angle outside of them. Okay. So. All right. If that's all that we have then for questions, what I'm going to do is use the remaining time that we have. I printed out the chapter review. Don't write on these, okay? I'm going to get these back from you at the end so 6th period can use them as well. But I listed a number of problems from the chapter review. I also listed the formulas that would be useful for you to know, okay? Obviously, your law of sines, law of cosines, your two area formulas, the magnitude of a vector, getting the unit vector in a specific direction, finding the dot product, cosine theta for the angle between two vectors, finding the component vector when you're given a magnitude and an angle. What has to be true about this angle?
Oh, it has to be.
Help us at least.
Wait.
What has to be true about the angle?
Less than 180.
Actually not necessarily, because remember we could use bearings and stuff too.
Oh, so romantic.
It has to be positive.
No, actually doesn't.
It's only going downward.
How do we measure it?
Like counterclockwise.
Standard position, there we go. This angle here, when we're doing the magnitude of f times cosine theta, sine theta, cosine theta and sine theta have to be in standard position. Notice back here, it wasn't an issue in this problem because we were going from the positive. If we look, quiet please, if we look at going from that point there where it's connected, we're going from the positive x-axis and rotating counterclockwise. That's standard position. Okay? Same thing here when you draw the picture. Positive x-axis, we're rotating counterclockwise. If you're drawing the picture yourself, you can make it work out that way. Okay? We've got a wagon, and it's getting pulled this way, but the handle is going this way at an angle of 25 degrees. Okay? Well, draw it so your angle's in standard position, and you can just use this formula as it is.
So we substituted 200 to 20 to the F.
A force of 20 pounds on a handle, that's 20 pounds. Okay, that would be the magnitude of F. This is our theta. And yeah, we would use our force vector our force vector would be 20 times cosine of 25 times the sine of 25.
So distribute it in the.
We distribute it in. Obviously, we would have to use our calculator to find cosine of 25 and sine of 25. But then our displacement vector, if we're pulling at 40 feet, that displacement vector
40.
is 40, 0.
So then you do the dot product.
And then we do the dot product of this with this to get the work.
So work is magnitude of the force times the force vector times distance.
Yes. That was an alternative formula. It was you're either doing it like this. Okay, that's work. Or if you knew the force that was in the direction you were going, which is what we get when we find this horizontal component, then you can do the magnitude of that force times the magnitude of your displacement. Okay? Now, in this application, you cannot use this. Alright?
Why?
Because we weren't pulling in the direction we wanted to go. We were pulling at a 25-degree angle.
Oh, okay.
We would have had to use, if you want to call this like a secondary force vector or something, a horizontal force vector, that's what we used.
But it is in the same direction. It's just not like they're both going.
They're not in the same direction. One's 25 degrees off.
But they're good.
It's math. Same means same. This isn't English. You know, where you can just kind of make stuff mean whatever you feel like. So. So. All right. Anyways, yes.
So for the equation unit vector in direction of vector v equals whatever, that one.
Yes.
I'm kind of confused, like how that works if vector v is in there twice, and we're solving for vector v.
We're not solving for vector v. We're solving for a unit vector in the direction of vector v. So we have some random vector that tells us which direction we're going, but we just want to go that way one unit instead of whatever vector v is going. Okay.
When we use a direction angle formula.
That is if you just have one vector and you want an angle for it. Remember, the direction angle was that angle in standard position. So it's kind of the reverse of this. If you look here at the force B over A, it would be sine over cosine, which is tangent. Okay? So, alright. I'm going to stop the video now, and we're going to start working on some of these. These are from the review exercises. I'll post these numbers on the blog as well so that you have them later. Then you can go back and work on more of these. I am going to ask you to leave these behind, but